All right, let's jump right into this explainer and uncover the invisible infrastructure that is literally powering our modern digital world. You know, every time you save a photo to the cloud, stream a movie, or run a massive backup, you probably picture these sprawling, futuristic server farms filled with blinking hard drives. But the reality? Well, it's actually way more surprising than that. The backbone of our data-driven society relies on a piece of technology that dates all the way back to the dawn of computing. Is magnetic tape dead? I mean, you'd probably think so, right? You might assume it went the way of the 1980s cassette deck, just some nostalgic relic gathering dust in an attic somewhere. But asking that question actually sets up the biggest misconception in tech today. Far from being dead, magnetic tape is quietly acting as the ultimate guardian of the global data economy. It's operating completely behind the scenes in ways most of us never even realized. The legendary computer scientist Andrew S. Tannenbaum famously dropped this fantastic quote, and it describes a concept the industry lovingly calls sneakernet. It's hilarious, but even before high-speed internet, physically driving a massive mountain of data on tapes from one building to another in a station wagon was frequently faster than transferring it over a network. Talk about original high bandwidth. And honestly, that principle of physically moving sheer volume still applies to massive data center migrations today. Okay, Section 1, Origins of Magnetic Tape, from UNIVAC to LTO. So our story kicks off way back in 1951 with the UNIVAC I computer. And get this, its Uniservo drive used tape that wasn't even plastic. It was literally a half-inch wide strip of nickel-plated metal. By 1964, IBM really shook things up with the 9-track tape for its System/360, making those giant, iconic open reels the absolute industry standard. Fast forward to 1984, those bulky reels shrank down into the single-reel IBM 3480 cartridge. And then, in 1997, the Linear Tape Open, or LTO format, hit the scene. Today, LTO completely dominates the enterprise landscape. It is a true legacy of brilliant, constant reinvention. Moving on to Section 2, How Magnetic Tape Works, the Mechanics of Memory. To really understand tape, we have to talk about sequential access. Think about a hard disk kind of like a record player. You can drop the needle anywhere instantly. That's random access. But with tape, to get to a specific file, the machine literally has to wind the spool to the exact right physical spot on the ribbon. It has to read in a continuous sequence. Now sure, that sounds incredibly inefficient for your everyday laptop, but for massive planetary-scale archives, it turns out to be a massive structural advantage. And the engineering here is just genius. You don't just write one straight line of data. First, you have linear recording, where multiple heads simultaneously write parallel tracks all along the length of the medium. Then, they stepped it up with linear serpentine. The read-write heads make a pass, shift over just a tiny bit, and write a whole new track in the reverse direction, basically sneaking back and forth without having to rewind. And finally, helical scanning, where a spinning drum writes short, incredibly dense tracks diagonally across the tape. It packs information in so tightly it almost defies belief. All right, Section 3, Tape versus Hard Disks, the Showdown. If we're looking strictly at speed, there is no contest. The hard disk dominates. Fetching your data on a spinning disk takes roughly 10 milliseconds. It's practically instant. A tape drive? Well, you might be sitting there waiting over 100 seconds just to spool the ribbon and find the file. If you need a database file right this very second to load a web page, tape is absolutely not gonna cut it. But tape secretly wins on scale. And this number right here, 20,000, this is the real game changer. Let's look at why. That 20,000 is all about surface area. A single modern LTO cartridge gives you roughly 20,000 square inches of recordable space. Compare that to a modern hard disk, which gives you about 200 square inches across all of its internal platters combined. Tape literally gives you 100 times the physical surface area to write on. When you're dealing with exabytes of data, having that vast physical surface area is just incredibly cost-effective. Which brings us perfectly to Section 4, Why Tape Survives Today, the Secret Superpower. For massive enterprise operations, it boils down to 4 undeniable advantages. First up, cost. It is hands down the cheapest medium for storing mountains of data. Second, power. And this is huge for green initiatives and budgets. A tape cartridge uses exactly 0 electricity while it's just sitting on a shelf, unlike hard drives that have to constantly spin. Third, longevity. Tape gives you decades of safe data retention, which you absolutely need for legal compliance. And finally, security. Today's massive robotic tape libraries are managing hundreds of petabytes of data precisely because they combine all 4 of these factors. And on that security point, we really need to highlight the air gap. An air gap is a physical security measure where the storage media is entirely disconnected from any network. Because a robotic arm can literally pull a tape cartridge out of a drive and stick it on a physical shelf, ransomware hackers and malicious viruses simply cannot touch it. There's no network connection. In an era of nonstop cyber threats, this physical immunity is without a doubt tape's greatest superpower. Let's dive into Section 5, the high-density future, beyond the cloud. If you thought tape was stuck in the past, just look at the insane density researchers are hitting right now. 201 gigabits per square inch. Sony actually achieved this mind-boggling milestone way back in 2017. To really wrap your head around that, this breakthrough translates to a standard compressed tape capacity of 330 terabytes in a single standard-size cartridge. They pulled this off using a vacuum-thin film forming tech to create unbelievably fine crystal particles on the tape surface. Just imagine holding 330 terabytes, which is basically an entire server farm's worth of data, right in the palm of your hand. But hey, science doesn't stand still. Prepare yourself for an even wilder number that is coming down the pipeline: 580 terabytes. In 2020, Fujifilm and IBM announced a staggering technological leap forward. By switching the actual magnetic recording medium over to a material called strontium ferrite, these researchers are paving the way for a single tape cassette to hold 580 terabytes. Guys, that is enough to store the text of over 500 million books on one single tape. It absolutely proves that this so-called retro format is actively evolving into the ultimate storage technology of the future. So, I'll leave you with this. Will you ever look at a cassette tape the same way again? The next time you seamlessly back up your phone's data, remember that your precious files aren't just floating around in some digital ether. At the very end of the line, they are highly likely being guarded by the oldest, most reliable, and arguably most futuristic physical tech in the book. It really makes you wonder, what other obsolete technologies are silently waiting in the wings to solve our future problems? Keep that in mind as you navigate the digital world. Thank you so much for joining me on this explainer.